Okay. All right. So I'll get started. So yeah, thanks for having me. I'm really excited to be here. I just want to give a quick shout out to Dimitri who spoke earlier. Dimi actually connected me to Stephanie, so I'm really happy to be able to speak to you about this idea. And I wish I could be there in person, but hopefully I'll get a chance to talk about this more soon. I have a lot of slides and a lot to talk about, so I'm just gonna like dive right into it. I'll tell you really quickly like a bit about myself. So I'm somewhere in between art and machine learning. I've been studying machine learning, computer science for most of the last 10 years of my life, but I've been kind of interested in both musical and visual art applications of machine learning. So I started out in this field of music information retrieval, studying things like recommendation systems. So that's kind of how I got interested in machine learning in the musical domain. I started doing things like building like these musical instruments that would use machine learning to train some sort of a digital audio synthesizer so that a performer can actually take one of these musical instruments and teach it how to play some sort of like a virtual instrument using machine learning in some sense. So this kind of got me started on thinking about more like creative applications of AI, and I started making a lot of visual art that was using things like generative models. It's something I'm going to tell you a little bit about in just a few slides, and also things like Deep Dream, for those of you who are familiar with a lot of the really cool like visual art applications of AI that have become really prevalent over the last couple of years. So doing things like this is just a little bit from my portfolio. You can kind of see a lot of this work online, doing texture synthesis. There's basically a texture synthesis of Google Maps, and it's kind of doing this infinite zoom. So if you've ever had like a really horrible nightmare where you're like looking at your cell phone trying to zoom in on Google Maps, this is what I imagine it kind of looks like. I do things like just having fun with machine learning. I'm really interested in trying to get people to find the lighter side of these techniques and try to, try to be engaged, because, machine learning is usually kind of brought up in the context of very typical sort of company, corporate things. And I think people really get engaged most when they're kind of doing like either artistic or funny applications like this. So here I'm just like inserting myself into various paintings and so on. So yeah, I was actually there. Also, like for anyone who's interested in this stuff, I put a lot of it online. I've been running this website called ml4a.github.io for the last couple of years, where I and some collaborators, we create a lot of like practical materials for people to get started with machine learning for artists. So things like instructional guides, Python, like Python code for generative models, training GANs, and so on. All of this stuff you can find online. I'm also really active teaching, so I record a lot of my classes and I put them online. So if you go to the classes section in ML4A, you see I just finished one at New York University about called the neural aesthetic, and it's basically an introduction to machine learning for artists, and so on. Okay, so the main thing that I want to kind of talk about is this idea of an autonomous artist, and this has been something that's been floating around for the last couple of years. I'm going to show a few kind of related ideas and talk a little bit about what I think I can add to it. The basic idea of an autonomous artist, or an autonomous artificial artist in this case, is it's basically a DAO, like a decentralized autonomous organization that creates and sells art, basically makes its own art, sells it, uses it to pay for its resources that it needs. And the resources that an artist needs are basically compute. Obviously, that's the big one, of course, compute. But also, in my case, data, because I'm interested in using machine learning systems that can continuously learn from a stream of data. So this brings in another kind of dimension to it, to have data rather than just using some sort of a procedural algorithm is kind of the point, and something that I want to integrate into this idea. So I've been really interested in this idea for a really long time. Like even before I was really familiar with a lot of crypto stuff, I was interested in how machine learning could be used to sort of bring about what I think of as the collective imagination. And what I mean by that is we're all generating tons and tons of data and centralizing it somehow, and we can use machine learning to make inferences from that data. And I think those when we generate images, I think there's something to be said about how we're tapping into the collective imagination of all people. This is something that I've been kind of expounding for a little while. I don't have enough time to really get into the details of that. I'm writing an article about it, which I'll mention later, that will try to kind of elaborate on this a little bit more. But in the age of generative models, we're really beginning to do incredible things, and a lot of it is kind of funny, but it gets just more and more realistic with time. So this is what you're looking at is an example of a type of generative model that takes in as its input a sentence and then generates an image based on that sentence, right? So neural networks' perception of what a woman eating a delicious sandwich should look like. And it's pretty funny, but for me, it's really interesting because these are entirely learned in an unsupervised way from all of our data, right? So from hundreds of thousands or millions of images that have been labeled by people. And so I think it's really trying to kind of in a computational way study our collective, the collective way that we perceive things, that the way that we write about images, the way that we describe them, and so on. This idea took a step forward for me when I first encountered this idea of the art DAO. And this is so I lived in Berlin for the last 2 years, and I got a chance to get to know Trent McConaughey, he actually runs the machine learning meetup in Berlin. And I gave a talk there about some of my work, and this is when I first began to kind of learn a little bit more about crypto, and I came upon, through my conversations with him, about this idea of basically using a blockchain to create an autonomous program that creates art. And this was kind of there's a couple of articles by Simon de la Rouvière and also by Trent, where they kind of give like a basic formula for some sort of a process that can make this autonomous artist idea. And their idea was kind of to basically use some sort of a public mechanism for selling the art, Getty or Shopify or whatever, where every time the program makes a piece of artwork, it timestamps it on the blockchain, and then it's able to transfer the rights to buyers using basically some cryptocurrency. And so I thought this was really interesting, and I've also been pretty interested by a lot of the other kind of art or creative applications that have been coming out in the blockchain world. So people are probably, of course, everyone's familiar with CryptoKitties, and there's also this new platform called Super Rare, which I'm casually familiar with. I don't know if anybody from either of these organizations is there. I think you guys are great. It's really, really interesting thing to me. And these are kind of like the crypto collectible scene is basically where you own some sort of an asset on the blockchain, which is characterized by some kind of DNA in a sense, right? So all of these are assets that are controlled by tokens, and each of the images are essentially characterized by some string of numbers, which describes the features. And this is actually really, really, really compatible with some machine learning stuff, which I'll talk about in a few slides. The closest thing that I've seen, and this is a small project, I'm not sure how far along they are, but there's this new project called Crypto, which maybe some people are familiar with. I don't think it's kind of has as much traction as CryptoKitties, but it's kind of along the same idea. It's like what CryptoKitties is, except instead of having some sort of a procedural generative algorithm for generating the cats, where some artist came along and said, okay, we have all these kinds of features, and they're being sort of brought together by in this sort of DNA string. Instead, what Crypto does is actually they train a generative model. So this is a machine learned generative model on a data set of anime characters or manga characters. And you'll see in a moment when I introduce these that these are also basically all of the images are functions of some string of numbers. And those numbers you can think of as a signature, which can be collected in some sense. And I think this is actually like a potentially very powerful idea, bringing in this idea of generative models into this framework. I also want to mention, so Autonomous is another project that I'm really interested in. So Simon de la Rouvière, who I mentioned, who came up with the Art DAO concept along with Trent, and also came up with curation markets, which I'll mention in a few slides. He has this project that he initiated called Autonomous, which is now kind of attempting to create this self-sustaining, self-improving autonomous artist. But for what I see right now, it's mainly using procedural algorithms. So basically, like a JavaScript that generates some sort of an artwork, but there's no sort of generative model functionality in it at the moment. So let me tell you about generative models. I keep on mentioning these. So basically, these are machine learned models that capture a data set and then can then synthesize samples that look like they came from that data set. So if you have 1,000,000 images of cats, then you're able to learn a model which takes it as its input this basically random numbers and produces an image of a cat. And it learns these in such a way that you have this multitude of images that you're able to generate. So you can train it on anything you want. So here, these are just examples of cars and screens and things of that sort. And I don't have enough time to get into the mechanics of this. I'll show you some later where you can learn more about this if you're interested in it. But basically, these are taking neural networks, which are, of course, very famous in the machine learning world, doing more or less all the stuff that we're excited about with deep learning is being done by neural networks. And neural networks people are usually familiar with in a really simple context. They're basically these very flexible algorithms that can learn how to do things like classification. So it gets an image of a dog or a doge, and then tells you that it's a dog rather than a cat or a piano or something like that. And now neural networks have become increasingly complex over the last few years. So we have neural networks that are modeling on the order of hundreds of millions of neurons, and sometimes or hundreds of millions of connections and tens of millions of neurons. They're getting bigger and bigger every year, and because of that, we're able to do more and more complex tasks every year. So let me skip this a little bit. There's some work that shows that neural networks are capturing these, in an unsupervised way, low-level features of images, in the sense that you can actually isolate what each of the particular neurons in a neural network are learning. So for example, like this is just some visuals from some work in 2013, visualizing cubnets, where basically the authors talk about how different neurons inside of a neural network become sort of responsible for identifying a particular type of feature, which can be very complex. So for example, this neuron is able to recognize things like lattices, or grids and things like that. This neuron is finding things like wheels, this one finds upper bodies, and this one finds text, and so on. And what's really amazing about this is that it does so in basically without us telling the neural network what the features are. So it's able to do this all automatically, essentially, which makes it very conducive to automation, right? Which is what blockchains are all about. All of these generative models are characterized by, whatever architecture they use, they have a sort of common schema, you could say, or like a common API, where you have some neural network, like let's call it F, and it's trained on a whole bunch of images, thousands or millions of images, and then the network is trained so that it takes in some random sequence of numbers, and then that random sequence of numbers translates into an image, right? And each image is uniquely identified by a single input, right? So this is kind of, you see how it's parallel to the CryptoKitties idea with the DNA assigned to a single image, except that there's this training process that learns it. So this is really great because then we can take, well, I'll get into this in just a little bit, but we can use systems that collaborate on bringing in a whole lot of data, right? Because it's very hard to collect data, but you can do it much better when you have a lot of incentives for people to pool their data together. There's a few different categories of generative models. So like autoencoders are kind of what you see on the left, which use this sort of process of compression. Unfortunately, again, I don't have enough time to get into the details, but but also generative adversarial networks, which people are probably most familiar with. That's what crypto is based on, that use these two neural networks in this sort of adversarial process to train a really, really effective type of generative model. And this, going back 3 years, this is what it looked like. So you could generate things like faces with these GANs, as they're called. So you could do arithmetic on the features and do things like add and subtract different features. I use this in a project called A Book from the Sky, where I trained it on Chinese handwriting. So you could do all this kind of cool stuff with generating characters and interpolating between them and so on. And what's really crazy about GANs is just how great they become year after year. So they were invented in just 2014, and they could synthesize faces at about 32 pixels. And you can see the progress year after year. At this point, we're making very, very high definition, nearly photorealistic images. So it's really hard to tell these apart from actual real faces. So you can see just how fast these are getting a lot better. And of course, they have the whole latent space idea that you can play with. So this is some work released by NVIDIA. Well, you saw these earlier. I myself trained one of these on a collection of paintings from WikiArt. So from WikiArt, you can get hundreds of thousands of paintings, open source, and throw them all together into one of these gigantic progressively grown GANs, and it's able to generate just, thousands of unique paintings, right? And you can see that they captures a whole lot of diversity, images that look very abstract and images that look kind of like manuscripts or portraits, landscapes, sort of more abstract works, and so on. And again, GANs just continue to get more and more realistic. These are all fake pictures. So this is some work by DeepMind just a few months ago. So it's a photorealistic dog and a cheeseburger and an island, and it's just really, really getting pretty crazy. I've been working with these big GANs. This is basically mixing owls and dogs. This is just a joke. So this is an owl generated by big GAN. This is a dog generated by big GAN. This is sort of a hybrid. So you can do this sort of like genetic modifications on these by putting these together. Here's another owl dog. And it looks like a character from Harry Potter, doesn't it? Like sort of Griffin. I don't know. Let me speed up a little bit because I'm running out of time. There's a whole other category of image-to-image generative models that can do things like generate faces, generate portraits of people. They are becoming increasingly realistic. So this is some work by NVIDIA. These are all synthetic faces. And the synthetic video game screens, just a lot of like really, really amazing work. I want to skip through some of this stuff. Okay, I want to mention a few of the components that are important to the autonomous artificial artist idea. So you guys are probably mostly familiar with this centralized machine learning idea where you have some AI company that transmits some service, usually cat videos, to a bunch of users, and they basically give all their data to AI Incorporated. AI Incorporated trains a neural network model and then provides a better service to the customers and then sells the data or the rights to the model or some API above it for some money, right? And this is kind of how centralized machine learning works. I think you, of all people, this crowd knows exactly all of the limitations of that, so we won't talk about them. But I'm really excited about a few ventures that are trying to basically come up with alternatives to this model, decentralized machine learning ideas. And one of the best ideas, I think, is in this space is OpenMind. I don't know if anybody from OpenMind is in presence, but this is a project that I'm really excited about. So the OpenMind team is trying to create basically a framework for decentralized private machine learning. So the idea is that instead of just having users sending their data to AI Incorporated and then having AI Incorporated train their neural network internally, instead you have this system where there's a smart contract and some sort of an oracle that lives in between AI Incorporated and the user population, and they actually send the neural network they actually send the model to each of the users individually. They download the model, they improve the model and by basically using it a little bit and adding some modifications to the model that make it a little better. All of those modifications go to the smart contract, which basically combines them all together and improves the model in a smart way. At no point does AI Incorporated have knowledge of any of the original data from the users. And this creates basically a framework by which potentially a population of users can actually collaborate on a model that is essentially co-owned by all of them. So this is really, really interesting. Also, like a few other components that are important to the artist idea. So Simon De La Rouviere, who mentioned, also came up with this curve bonding idea. I really am running out of time, so I don't. I think probably most of you are familiar with this, but basically you can use this to seed like something like a curation market or a continuous organization. So basically, where a bunch of users can collaborate with a token to basically collaborate on some sort of an organization together. Token curated registries are another example of this. Unfortunately, don't have enough time. But yeah, I would definitely go to all these links to try to understand the things that you can do. I think I'm running out of time, so maybe just give me another 2 minutes, and then I'll be done. So it's important to note the sort of broadness of the idea of curation, right? So you can think of even a software repository as a curated as something that uses curation to be managed, right? In terms of feature requests and pull requests and things like that, those can all be tokenized, and to create some sort of a system for managing even a software repository or an organization in a decentralized fashion. So basically, the idea is that you can combine all of this framework for decentralized machine learning using like token engineering, curation markets, and large-scale social coordination inside of a DAO that implements a generative model, right? So here's the idea: you have some sort of a DAO which has a generative model, and all of the users can contribute data, so image in the form of images, sounds, text, whatever, images, data, compute, and whatever other resources the model needs in order to be trained. And then the model generates artworks, which can then be sold to other users.
Sorry.
Oh yeah, running out of time. Yeah.
No, I'm cutting you just to tell you that you can take 5 more minutes, so that you
Oh,
can slow
5 minutes.
down a bit in your pace and take more
Okay.
time
Yeah,
enjoying.
I'm sorry I'm rushing. I think I put together way too many slides. Okay, yeah. So yeah, let me kind of back up on this and kind of describe the idea in a little bit more detail now that I have some time. So here's the idea, right? So you have a DAO, and it has some sort of a framework for collecting data in a decentralized way, like using the technologies that I just mentioned, and collecting data and training a model to generate images based on the data. So you have this kind of a setup where there is both value going into the DAO and value coming out of it. The value that goes into it is the data, right? So people that contribute data could be potentially compensated, right? So you have a situation where the artist owns the work and can sell the work to patrons who wish to essentially mine artworks out of it. But at the same time, the organization is able to compensate users who contribute data and data, code, and compute. Those are kind of the three components that you need. Potentially, you can work in things like curation markets because, of course, curation is something that's very necessary for art. And obviously, like a curation market can also be used to mediate governance of this if the organization that does this is fully decentralized. So that's the basic recipe. And it's very much in line with autonomous and other proposals that have come out in this space. The only real innovation is kind of plugging in a generative model. And the reason why generative models are so conducive to this idea is that they kind of provide a very homogeneous interface, right? So you have this idea where every image that's generated by this is associated with a particular, basically a random sequence of numbers. And so you can think of that as that could be a token that you trade, right? So there's a whole lot of permutations of this idea and I'm still working them out myself. I haven't really decided exactly what works best, but that's the basic idea. Okay, so let me really quickly announce like where this is all going. So I am in the process of writing an article to introduce a project that I'm calling Abraham right now. This is the logo that I came up with, and basically Abraham is going to be, I hope, a project to build an autonomous artificial artist. I think it's very, very much compatible with the projects that I just mentioned, particularly autonomous. And what I'm hoping to do is I'm in this space of machine learning and teaching it a lot. I have an audience that's basically interested in creative AI, and I'm hoping to kind of try to get people just talking on a Slack channel, and then basically creating some software to maybe realize or study this idea. And because I'm not really sure exactly how it should be built. I'm personally myself very inexperienced with crypto. My background is in machine learning. So my first idea is really to try to get the basic idea out there. And before anything is implemented, I want to kind of see the Slack channel and a GitHub organization, maybe even explore some of these governance mechanisms that might give it some sort of a way to kickstart it. And I've been writing, those of you who know me, like I've been writing this article for like a year now. I'm a really, really, really slow writer. I was hoping it would be done by now, but it's not. However, I should be hopefully posting this in the next month or so, maybe month or two. And then there's nothing on this website right now. It's just a landing page, but basically on Abraham.ai, it'll contain links to all this stuff. And I'm not really sure how this should work, or what exactly the mechanisms to make it work should be, but I'm hoping to just get the idea out there, get as many people interested in it as I can, and then at some point start a discussion about how this can actually work, like more concretely. So that's the idea of Abraham. One project also I want to mention really quickly is I'm going to be teaching a class at ITP, like this is at NYU, which is called Autonomous Artificial Artists, and it's basically an attempt to do this at a very, very small scale with a group of students. And I'm going to use this as a springboard into sort of how mechanisms for this. This won't really have much of a crypto element. It'll be really mostly focused on how to combine many people's contributions into a collective artwork, because that's a necessary component. So this is kind of something to keep an eye on as well. Okay, so that's all I had for you. If you have any questions, I'd be happy to answer them. I'm really hoping that people kind of keep track of this project, and if you want to follow my work, I'll be announcing it through these channels. And I'm really hoping to get as many people interested in this world to collaborate with me and make something really neat. So yeah, that's all. Thank you.
Thank you very much. You can give an applause. I don't know if you could hear it, but yeah, really enthusiastic. Yeah. I was wondering how many lives you have. Are we taking time for a question here? I know Berlin cannot talk, but is there a question? We have time for one question. Be quick, be sharp.
Yes, how does the autonomous artist choose what he will make? Like normally an artist has some inspiration or a kind of style of his paintings or whatever what he makes, but how does the machine do it? Because is there like I saw the last picture of people paying something. Are those the people who say I want something like abstract painting with the colors purple and yellow, for example, or does it choose itself?
So there's a couple of ways I've thought about this, and the first way that you can think of would be some sort of an interface that lets people, patrons who wish to buy artworks, they could potentially like try to either pick the numbers themselves that generate the artwork, in which case you can think of it almost like mining. So well, they're mining artworks from it. And maybe they can, like you said, like specify certain characteristics that they wish to, and then kind of reverse engineer from there. That's one way of doing it. Another way is I've become familiar with this technique called deep interactive evolution. There's a good paper about this by Julian Togilius and some of his collaborators, where you can actually use a mechanism to get feedback from a population of patrons. So people are basically interacting with the artist and generating artworks, and then they are giving it feedback, like I like this, I don't like this. And from that feedback, you can actually attempt to predict automatically what artworks are likely to be most popular, and then basically try to generate those. There's also a lot of work in reinforcement learning, which is a branch of machine learning that's concerned with trying to create autonomous agents. So maybe if you have something like, like agents that work autonomously, basically. There's a really strange thing where there's a lot of common goals in the blockchain world as well as with the machine learning but they're not really interacting. So, reinforcement learning is all about creating autonomous agents, right? So that's very, very much in line. But anyway, I digressed a little bit. So like the idea would be that an autonomous agent could actually learn how to basically pick curate its own work. So just like if you were an artist and you were curating your work, you can actually do this using machine learning as well, based on the feedback of the market. So something like that. I'm not exactly sure how it should work, but those are like some basic rough ideas.
Thank you very much. Thank you again, Jeannie. You can again applause him.
Yeah, thanks for asking me.